Good day to all. Today we are going to see about the stepper motor. What is that? Stepper motor. See the principle of stepper motor. Stepper motor is an electromechanical device which converts the electrical pulses into discrete mechanical movements. The shaft or spindle of a stepper motor rotates in discrete steps, increments when electrical command pulses are applied in a proper sequence. The main purpose of the stepper motor here it is converts the electrical pulses into discrete mechanical movements. Discrete mechanical movements. Then the motor rotation has a several direct relationship to these applied input pulses. The sequence of the applied pulses is directly related to the direction of the motor shaft's rotation. The frequency of the input pulses and the length of the rotation is directly related to the number of input pulses applied over here. Then we are going to see the types of stepper motor. What are all the types of stepper motor? First one is variable reluctance motor, then permanent magnet motor, then hybrid motor. See, this is the variable reluctance motor. Here you can see there are 6 pulses. Here 1, 2, 3, 4, 5, 6. These 6 are will have a winding on over on in it. According to that operation, this will going to takes place. Then we will see that this one is a permanent magnet motor, and this is the hybrid magnet motor. Inside there is a stator as well as a rotor is there inside these motors. Then when we want to use this stepper motor, that we will going to see. See, stepper motor can be good choice whenever the control movement is required, because if we need a control over that machine, we want to use that stepper motor. Then they can use advantage in that applications where we need the control rotation angle, speed and position and synchronization. But because of these inherent advantages listed previously, stepper motor have their places in the different applications. Because of that we need a control rotation angle and the speed, position and the synchronization. With this we will have the inherent advantages for this stepper motor. See, these are all the stepper motor characteristics. First one is stepper motor or constant power devices, and as the motor speed is increased, torque is decreased. Here the main thing is if the motor speed is increases, then the torque is decreases. Then the steppers exhibit more vibration than other motor types, as the discrete steps tends to snap rotor from one position to another. Then this vibration can become a very bad at some speed and can cause the problem of that particular motors. This is the torque generation of the stepper motor. First one is step rate, the second one is driving current in that winding, third drive design. Now the basic relationship which defines intensity of that magnetic flux is defined by H equal to N into I divided by I, where here H equal to magnetic flux intensity and N is the number of that winding. Then the size and power of that stepper motor. See, addition to being a classified by their stepper angle, stepper motor are classified according to the frame sizes. Depending upon the frame sizes, they are classified, which correspond to the diameter of the body of that motor. For instance, size. The stepper motor has a body of diameter approximately 1.1 inches. It has a 1.1 inches. Likewise, a size 23 stepper motor has a body of a 2.3 inches, which is 58 millimeter. The body length may, however, vary from motor to motor with the same frame size classifications. As a general rule, the available torque output from a motor of a particular frame size will increase with the increase of body length. The power loss for the IC driven in the stepper motor typically ranges below a watt for a very small motors up to 10 to 20 watts for the larger motors. The maximum power dissipation level or thermal limits of the motor are seldom clearly state that in the motor manufacturing the data. See the rotating magnetic field. A phase winding of a stepper motor is energized with the current magnetic flux which is developed in the stator. Then the direction of the flux is determined by the right hand rule. The magnetic flux path developed when phase is energized with the winding current in the direction. The rotor then aligns itself so that the flux opposition is minimized. In this case, the motor would rotate clockwise so that its south pole aligns with the north pole and the north pole is aligns with the south pole. To get a more rotate, we can provide a sequence of energizing the stator winding in such fashion that provides a rotating magnetic field which the rotor follows due to that action. See, this is the torque versus angle characteristics of that angular position. If you will see here, this one is a stable point and this one is an unstable point, and these two will have an unstable region. This is again the stable point. Here you can see that angle of TH1 and TH2. This between the rotor torque versus the rotor angular position. This is the torque versus rotor angle position with the different holding torques. This is also the one of the characteristics with torque versus speed characteristics of stepper motor. This is the single step response of the resonance. You will see that the angle and the time certain limit it will increase slightly and it will step over that saturation period. Then what are all the advantages in that stepper motor? See, first one is the excellent response to starting or stopping or reversing in the stepper motor. And then it is possible to achieve very low speed synchronous rotation with a load that is directly coupled to the shaft. Then the motor response to digital input pulses provides a open loop control which making the motor simpler and less costlier to control. Then the motor has a full torque at a standstill if the windings are energized. This is the main advantage of that stepper motor. Then the disadvantage of this stepper motor, mainly resonance can occur if not properly controlled. Some resonance will occur if not we can properly control that stepper motor. Then the second one is it is not easy to operate at extremely high speed. If it is going to high speed or if it is running in that high speed, we cannot easily to operate to this stepper motor. These are all about that stepper motor. Thank you.